Hey there, welcome back to the channel. Today we are going to cover another LeetCode problem that is contains duplicate. So let's see what our problem is saying. We are given an integer array nums and we need to return true if any value appears at least twice in the array. And we need to return false if every element is distinct. So let's see this with an example. So we are given an array nums having values 1, 2, 3 and 1. And we need to return true if any value appears at least twice. So here we can see 1 appears twice, so we'll return true. Let's see another example. We are given another array nums 1 2 3 4. Here the values are distinct, so in that case we'll return false. So let's see how can we solve this problem. So in this problem we are given an array of integers. We have to return true if the array contains duplicate. In this array we can see we have duplicate 1 appears twice and 2 appears twice. So we have to return true. If we are given this array of integers, here you can see 1 appears twice. So we can return true as this contains duplicate. If we are given this array of integers, here we can see 1 appears 3 times and 3 appears 2 times. So here are duplicates, so we can return true. And if we are given array nums equals to 1 2 3 4, here we can see that there is no duplicate in this array, so in that case we can return false. So this is our problem. So first let's talk about how can we approach this solution. So let's talk about the brute force approach. In this we are going to run two nested loops. By running two nested for loop, we have the first element and we are going to search 2 on the right, and 2 does not exist on the right. Now let's search for the 1. So 1 does not exist on the right. Let's search for the 5 on the right. 5 exists here. So if we find the duplicate, we are going to return true. But this is not the most efficient solution. And this solution take time complexity of O of n square and space complexity of O of 1. Space complexity is good, but the time complexity is not efficient. Can we improve this time complexity from quadratic to any better? Yes, we can solve this problem by sorting our array in O of n log n plus n time complexity. If we sort this array, we can get 1, 2, 4, 5 and 5. This array is sorted, right? We have sorted this array. Since this array is sorted, we can check the pair. First pair, we see this pair 1 and 2, these are different value. Then this pair 2 and 4, not the same value. Let's move forward. 4 5, not the same value. Let's move forward. We have find the same value, so we are going to return true if our array is sorted. If we compare the pair, we'll find out the similar element. If we have duplicates in our array, we find it here in similar element, right? So we have returned true. This solution takes linear logarithm of time complexity and space complexity of 1. Or now can we improve this time complexity to O of n? Yes, we can do that. Now let's try to understand the logic of efficient solution. So let me create another array nums. We have here 5, right? Let's assume we reach this element by visiting 2 and 1. From the left, we visited 2 and 1 and we reached at 5. Now, can you search 5 on the left? Yes, we can. But how to search 5 on left? Does 5 exist on left or not? How can we search that? We can search that using a loop, but that is not efficient. Instead, if we can keep track of visited element, so if we encounter 5, so we can check does 5 exist on left or not. We can check the visited array. But how to check this efficiently? For this we can use set data structure. We know that we can check in the set data structure in constant time. So if we search this 5 on the set data structure, whether 5 existed or not, it can gives us the result in the constant time complexity. So we see 5 does not exist. So we are going to move forward and we are going to save 5 here. Now we'll check, does 4 exist on the left? No. So we'll save it here. Now again we'll move forward and we'll check, does 5 exist on the left? So yes, 5 exists on the left. So we will return true. Let's start from very beginning. And this is our set data structure. So first element is 2. Do I have an element on the left of 2? So no, we can add. Now moving forward to 1. Do I have an element on the left of 1? So no. So we'll add in the set data structure. Moving forward, 5. Do I have an element 5 on the left of 5? So answer is no. So we'll save it here. Moving forward, do I have an element 4 that is on the left? No. Let's move forward. Here we have 5. Do I have an element 5 that is left of 5? Yes, it is. We see 5 exists in our set. So we have to return true. This solution take time complexity of O of n and space complexity of O of n. This is the most efficient solution. So I hope you have understood this video explanation. So now let's implement this algorithm, and in the implementation we are going to change the set name to visited. This is for better naming convention. So now let's implement the algorithm. First let me create our set data structure hasset, and in this we are going to set integer as visited equals to new hasset. Now we are going to iterate over array of integers. So for int I equals to 0, I is less than nums dot length and I plus plus. Right inside here we are going to check if visited dot contains nums of I. If our current element existed on our set, then we can say we have visited the element previously, or we can say our current element occurred more than once. So we are going to return true. So we have finded the duplicate. If this statement returning false, then in that case else. So we are going to store our current element in our visited. So visited dot add and nums of I. If this if a statement never becomes true, then our array contains no duplicate elements. So again we have to return false. So this is most efficient solution, and this solution takes linear time complexity and O of n and space complexity as O of 1. Let's run this code. So yes, it is accepted all the test cases. Now let me submit this code. So yes, it is submitted successfully. So I hope you like this video. If you have any doubt, you can ask me in the comment section. And if you like this video, please subscribe, share with your friends. Thank you, and I'll see you in the next one.